know I was doing this 5 minutes ago. All right.
Oh, well.
Good morning, everyone, or good afternoon, good night, depending on where you are in the world. If you are in the time zone of this conference, it's actually 9 a.m. at the moment. Where I am in Australia, it's 4 p.m. And where Mark is an entirely different time zone again. And isn't it just wonderful that we can meet like this these days and have a virtual conference that brings together the global community of data science and AI specialists. And today we are starting the 5th version of the Big Data Conference Europe. My name is Jonas Christensen, and I am myself a data scientist. I'm head of data science for a large organization in Australia. And I'm also the host of the podcast called Leaders of Analytics. And I've spent many years in this industry now and seen how it's grown over time. And I'm just more and more excited every year I spend in this industry. We have such a lot happening in the tech and data science space, but in my opinion, we're not even 5% into the journey that we're going to go through over the next 10 plus years. Today, we are live streaming to more than 15 countries around the world. So thank you everyone for joining in from wherever you are. And before we get to the first keynote speaker, a couple of things I just want to tell you about is, first of all, we have our silver sponsor here this year, which is Accenture, which is a global professional services company. And they are our sponsor. They provide a large range of services and solutions in strategy, consulting, digital, technology, operations, etc. We also have a knowledge partner for this conference, which is Pact. You might have seen Pact books out there. There is actually one sitting underneath my computer right now. Here, I can tell you to lift my screen up. So I myself have used Pact books many times to learn. And Pact is our knowledge partner, which means that you can actually win a Pact book of your choice if you are active throughout this conference. So the most participating conference attendees will have the opportunity to receive a book of their choice from Pact. So how are you going to be active? Well, rating sessions, interacting with sessions, asking questions in the Q&A section of your screen, those sorts of things. We're keeping an eye on those in the background. And the more you interact, the more likely you are to receive one of these books from Pact. So I really encourage you to interact with the platform as much as you can, because it adds to the conference itself and to your fellow attendees. Now, that's enough from me. And I will now go and introduce our keynote speaker, our first keynote speaker to open the conference, which is Mr. Mark Grover, who is the CEO of Stemme.ai. And
thank you, Jonas.
Mark is going to talk us through how to trust your data. So without further ado, Mark, I will just hand over to you to kick things off. Welcome to the stage.
Thank you very much. Thanks for having me. Appreciate the intro, and good morning, good afternoon, good evening, everybody. Thanks for waking up bright and early or staying in the afternoon to hang out with me. And the topic that I wanted to share with you is the problem that's happening today is that organizations have a lot of data. And in my opinion, the key problem that remains to be solved is how can data users trust this data? And I wanted to come today and share my take on the problem. In some ways, we have failed to solve this problem. And in some ways, we are trying to experiment, trying to solve this problem. A little bit about myself. I am the co-founder and CEO of a company called Stemme. And prior to that, I created an open source project called Munson, which is an open source leading data catalog and metadata engine. Prior to that, I worked as a Spark developer at Cloudera and was Apache PMC on a few different projects. I also ended up writing a book with O'Reilly called Hadoop Application Architectures. This is back when Hadoop was a thing, I guess. and that sold over 10,000 copies. So I've been in the data space for quite a while. But like I said before, the problem I'm here today to talk about is this problem of lack of trust in data. And this problem starts with just the growth that we have in data. So we've seen charts like this before, but the idea is pretty simple, that we have seen 30x growth in data over the last decade. And this could apply to industries, to within companies, and so on and so forth. The way it manifests within the company is that we have tried to store, process, and ingest this data. And innovation has made it really easy in order to do that. So for example, the very first thing that we've done is we as a data community have started using data warehouses. And these data warehouses are now super easy to stand up. Snowflake, BigQuery, Redshift can be stood up at the click of a button and a credit card. When we have gotten a data warehouse that we want to centralize all our data for analytics or data science, we then ask ourselves, what data do we want to bring into this data warehouse? And the first things that come to mind are third-party applications. So you may have a CRM system like HubSpot or Salesforce. You may have a NetSuite like ERP system. You may have other systems like Zora, Magento, that you use to actually bring data into the warehouse and you want to do some analytics on. So that becomes the first choice. After that, we say, oh, we've got all these production databases, which may be serving a website or a phone app or something else that we want to do analysis on and be able to look back. And often the first attempt at this is to do replicas of these data warehouses and then do these databases and do some analysis on it. But eventually you want to bring them into the data warehouse as well. Lastly, you have events, and these events are events that are tracking activity on your cell phone app, your web app, or your services. And these events are then sending information that Jonas just clicked the zoom in button, or Jonas just requested a ride by clicking the request ride button. So carrying on with this diagram, what we have done as an industry to handle large amounts of data is we have innovated. We have innovated in creating data warehouses, and we have tried to connect these three different kinds of data sources into the data warehouse. And in particular, we have tried to connect that using technologies, and we have innovated and created those. Fivetran and Stitch were both created in the last 10 years or so, and they have brought this data in, this deluge of data into the data warehouses, right? So now our data warehouses are flush with source data or base data. Then we have soon realized, oh, we actually need to be able to join these data sets. So I want to be able to join my Salesforce data with my data that's coming from my MySQL production database, right? So then we have created products like dbt and Airflow that allow us to create and process this data, put it back into the warehouse, therefore doing an ELT. Now we have even more data in the warehouse, and what we've done is we've exposed this to some users through BI tools. So Looker, Tableau, Mode, and many others come into this picture. And then we have built a culture of data-driven decisions where we have data scientists, data analysts whose day job is to make decisions with data. And we've made business users and product managers and other folks hired to be citizen data scientists. We have asked them to make data-driven decisions, right? So all in all, if we were to step back, data is increasing within the organization. We've made it really easy to capture, bring more and more data into a centralized repository, that being the data warehouse. We've made it really easy for you to purchase a data warehouse. We've made it really easy for you to then expose this data warehouse data to a BI tool. And we've hired a lot of people who want to use data, who are hungry for data in their day-to-day world. And then you ask yourself, well, what's the problem, right? The problem is now we have so much data that it's led to a bunch of bottlenecks. And the first bottleneck that I will talk about is this. For all these users who are data-driven decision makers, it's led to questions that are very commonplace today. A sales manager may come to a data team today and ask, do we have sales data tracked by region for a particular kind of product that we sell? Has someone done analysis on that data already? Can I just reuse a dashboard that exists? Oh, I see four different sources of sales data. What is the source of truth? I have a few other questions. Who owns it? I want to ask a few users who actively use this data. Can I get a list of the last 20 users who have used it in the last 30 days, right? And lastly, I want to query this data. What are some of the best practices for me to query this data, right? If you have asked these questions about data in the last month, go ahead and chime in on chat and say that this problem is visceral, right? And so the problem I'm trying to share is that because there's so much data, it has led to a lot of unknowns that are in people's mind that leads to questions like these. The second side effect is that people are now starting to write queries that are redundant. A very common style of query that's redundant is a select star from my table where a partition column is yesterday, limit 100. This query does nothing useful except tell the user what a preview of the data looks like. And the problem is a lot of people are doing the same queries over and over again. That leads to wasted productivity, obviously, but also wasted compute resources on your data warehouse. And lastly, and in my opinion, most importantly, it's led to a very interrupt-driven culture. And I, for example, was at Lyft prior to starting Stemma. And at Lyft, we had a Slack channel called Analytics Questions. And that this Slack channel would be where all these data users would go and ask these questions, the questions in the first category of side effect. And what you would find is that you could never answer these questions. The information in this channel got really overwhelming, and we had to put one data scientist on an on-call rotation every week to answer these questions. And this got really, really detrimental to the health of the science team, because this data scientist would be from marketing and they have to answer questions from marketing, from sales, from customer success, from operations that entire week. And at the end of their on-call week, they'd be ready to quit, right? And more importantly, because they don't know about all these areas, they're pinging other people during the week, asking them for their opinion or validation. Thereby, one data scientist on call is now getting 20 people involved in a week, all of which are getting interrupted to ask these questions, right? And this is the primary problem now associated with trust in data. Because there's so much data, no one knows what's trustworthy. We have increased load in our databases, and it's leading to an interrupt-driven culture. This leads to massive productivity problems. In a survey that we did at Lyft, we found that over a third of data user time was spent in discovery and validation. These are the questions are, what data exists? Can I trust it? And if you look at the workflow of any data-driven decision maker, you can divide it into 4 categories. The first category is discovering data. I'm doing analysis on ETAs, which is a time a driver takes to get to you, and I want to optimize, that is, reduce that time further. For that, I have developed an ML model, and I want to see the results of my current model's predictions with the actual model's ETA. Except I don't know what the source of truth of ETA data is in my warehouse, so I'm going to go ask. That's the discovery problem. Then when I'm asking, I may find 200 columns related to ETA, and I'll talk about why there may be 200 columns. But then out of these 200 columns, I need to figure out which is the source of truth. And that is exploration. I need to figure out if it has too many nulls. I have to figure out if it has the right distribution. Before I can actually do the work that I want to do is compare my predicted ETA with the actual ones. That is the first 2 steps, discovery and exploration. Over a third of the time is spent in those. The last 2 steps, which is modern development and productionalization and visualization communication, are the steps we pay these data analysts, data scientists, product managers money for being part of the organization, for doing their job. That's the stuff they enjoy. The first 2 steps are stuff that's wasted time. So we were wasting over a third of the data user time just because of this, right? And so this is a big problem. And the way we've tried to solve this problem is in a few ways. The very first attempt in an organization to solve this problem is to use wikis. So what you do is you create a page per table, or maybe you create one page for all tables, and you document key attributes in that table. You say, this is a source of truth for ETA data. Here's the particular column that you should use. Here are the gotchas associated with that. It's pretty easy to set up, but the problem is that it gets out of date very quickly. Not just because the documentation is handwritten, but also because the structure of tables changes. Columns get renamed, new tables get added, existing tables get renamed, and all of that information is lost in the wiki context. So that's a big fail. Often the second attempt that gets done here is a Slack channel plus on-call, which was similar to what I was describing before. In this case, data users are already using something like Slack in their day-to-day workflow, and you say, well, gee, why don't you ask questions on Slack and maybe search your answers on Slack in a particular channel, and then we can find information about data that way. If this is a solution that you use at your current company, I'd love to hear. Please chime in the Q&A. And then the con here is that this information gets really unwieldy very quickly. Slack isn't a product that's made for exploration, discovery of data. Slack is a product made for communication, right? So this turns out to be a failure. And lastly, there are attempts to make this problem be solved by a category called curated data catalogs. These catalogs create pages for you per table, and you can then type in descriptions for these pages. If a table gets renamed, this page automatically gets renamed with the new table name, and their documentation stays around. So it works really well for organized data dictionary. The con here is that you still need people to write documentation. These people are often called data stewards. You could have in some companies data stewards that are full-time data stewards. That means their job all day is to make sure that data is well documented and certified, and that documentation is up to date. But often you would have volunteer data stewards where someone has a day job as a BI engineer or a data engineer in a particular team, and it's also their responsibility to document data and maintain documentation about data. Now, there are big problems with data stewards, and they do a really hard job, but if you have a full-time data steward culture, you would find that you can never hire enough data stewards in order to maintain all your data in a fast-growing organization. And if you have volunteer data stewards, you'll find that you cannot get these people to consistently update documentation, well, because they have a day job. They are like data engineers and they have to maintain their data, and documentation, updating it is not the most exciting job, and always gets overlooked. And I have found time and again that these efforts also tend to fail. So I've told you what the problem is, what has led to this problem, and then I've told you 3 ways in which I have seen this problem be consistently solved and failed. So the question is, okay, Mark, how do we actually solve this problem? And well, I can share with you how I have thought about solving this problem in my past context and today. And so the key to solving this problem, if we were to step back, is to reduce the time that's spent in finding trustworthy data by building a versatile, automatic data graph. And then you expose elements in this graph via various different means. So a mean where you could expose this element is search, where you could say, I'm searching for ETA data. Tell me what's the most trustworthy data set or dashboard for ETAs. What does it contain? You could also search for, has someone done this analysis already? Maybe so that I can reuse that analysis instead of creating it from scratch. Then you can expose it via lineage. So you could show parent-child relationships between data sets, between attributes or columns within data sets, between data sets and dashboards, between owners, individuals, and data sets. So you could look at a particular data set and say, who are the people who own it? Or more interestingly, who are the people who most commonly use it so I can notify them? Then you can expose them in a network-based, which is the same thing as lineage-based, but applied to people. I want to follow a user. I'm joining Anna's team, and I want to see what data sets or dashboard does Anna use every day. I want to bookmark a bunch of a bunch of data sets and then be able to get notifications when something changes of them, essentially get a timeline feed of data. And lastly, because we can't anticipate all the use cases, we want to be able to programmatically pull this data out from the graph as well as push more data into the graph, right? And that's really, once you start to build this metadata graph, maybe we start to solve this problem of trust in data through automated means that's populating the graph. And when we talk about metadata, there are two things about metadata. Metadata is essentially a set of data about data. So we have to talk about what kind of meta information are we collecting and on what kind of data. And the information that we are collecting in metadata is what we call ABCs of metadata. This is a terminology borrowed from a paper called Ground. And ABCs of metadata say that the first kind of information we want to collect about data is application context, which is where is this data? What are the various fields in this data? What are the various types of each of those fields? Is it a string? Is it a varchar? What are the semantic types? Is it actually a name or is it an email address? So on and so forth. The second category of information is behavior. Who's using that data? What jobs and what people? Same thing with who created that data. What jobs created that data and who was the person who gets notified when that particular job failed. And lastly, change. How is this data evolving over time? Like how is the data or the code that produced this data changed? And what are the query patterns on this data changing over time? And so these are the three kinds of metadata that we need to support in order to be able to answer and expose the graph we were talking about. The next question is, what do we expose this metadata on? And the answer here is any data that exists within your organization. That could be your data warehouse or S3, data lake. Could be information about people that I and Anna are in the same team, and that is interesting information because I could be pushed data sets of interest that Anna uses every day. It should include information from your dashboarding system, from your notebook system, from your event schemas, as well as streams of data that are flowing in. So that's the place where I was at Lyft, looking at this problem of a lot of data at Lyft, with a lot of attempts being made to solve this problem and that had failed thus far. And I was looking for a solution where I could ingest all this metadata automatically and then expose it in those various ways. That led me to create a project at Lyft called Amundsen. Amundsen is named after Roald Amundsen, who was the first person to discover South Pole, and we thought it was smart to name a data discovery, data exploration project after a famous explorer. But at least in the States, and perhaps in most Europe, no one knows how to say that name, spell that name, or remember how to spell that name if you have a website or something like that. So in retrospect, it was probably not the best choice, but it has served us well. And so what I wanted to do today is, instead of telling you more about Amundsen, I wanted to show you what Amundsen looks like. And what I'm going to show you a demo of right now is Stemma, which is a managed version of Amundsen, but the core pieces remain the same. So I'll switch my tabs here, and yes, this is working. And so the most common use case here would be for a data scientist to come in and say, I'm searching for COVID cases data. Pardon me as I log in here. And you will just come in and search for COVID cases data. And this data is now being searched from data sets that are coming from your data warehouse, like Snowflake or BigQuery, as well as dashboarding systems like Tableau, Mode, Looker. And both of these results are page ranked, which means that more heavily queried data sets, and when I say query, I mean queried in the data warehouse, are showing up higher than less highly queried data sets. Same thing with dashboards. More highly viewed dashboards show up higher than less highly viewed dashboards. So you click on these on the search results, and you see a list of 5 data sets that are related to COVID cases. And you can see that the first one is related to cases, age, county, so on and so forth. And the ranking here suggests that I can click on the statewide cases data, and maybe that's the one I need to use. And what we need to do right now is quickly establish, as an analyst, whether it's something trustworthy that I can use. And so the few pieces of automated information that can help with trust is, when was this data set last updated, right? Because if this data set was updated a year ago, then it's not relevant for me anymore. Also, say I'm doing analysis on COVID cases data in Q4 of 2020, and I want to make sure that the date range here is valid between what I want, right? And one thing that automatically gets shown to you is via metadata of your data warehouse is what is the first date for which you have data and the last date for which you have data. And lastly, often when people want to talk about trust, they look at who are the other people who are using it, because other people are a proxy for how trustworthy a particular data set is. If Bob, who's another great data scientist, uses it quite often, then I trust that data. And the last thing I use for trust automatically is, what does this data come from? And so automated data catalogs are able to parse out the information from query logs and show you that this particular data set comes from these two other sources. And often you know that this source is good or the source is not good, and are able to quickly establish trust. So in very quick ways, this product is able to show you what trustworthiness looks like for data within the company. Once I, as an analyst, have figured out statewide cases is a good data set for me to use, I then have to figure out, okay, how do I join it with the other data sets I need to join it with in order to get to my analysis? And for that, in the past jobs, I have created ER diagrams. Now, ER diagrams are great because they show relationship of various entities in the data warehouse, but they get out of date really quickly. The moment you create an ER diagram, the moment it's out of date. And so one thing that I think we need to do more of is to leverage query logs in particular and be able to parse them to show join patterns. These join patterns can be helpful for a user like an analyst to see how others are creating this data and joining it. They're also super helpful for a data engineer or a BI engineer to see how people are querying this data to maybe create new data sets based on the patterns that are emerging, or correct erroneous patterns that are also emerging. And so one thing that I found useful is something like this common joins conditions, where you can see how commonly this particular data set gets joined with other data set and what clauses. Again, it helps both the producers of the data, which are data engineers or BI folk, as well as the consumers of the data, who are analysts. And lastly, it's interesting for me as an analyst to know what analysis already exists. So in this example, I can click on a particular dashboard page and see that, oh, there is a dashboard that's been viewed 2,100 times in the last 30 days. It was created or last updated on this particular time, which is pretty recent, and the last run was green. I could even see what queries this dashboard runs, so I could understand very quickly that maybe someone's already built a cases by county query that I can reuse instead of rebuilding that from scratch. And lastly, I could see, oh, I need to join this data set for senior. I'm doing this analysis for senior citizens, so I need age data set. And I can look at a particular data set like age and see, oh, how do I represent senior citizens in this particular data set? And here I could see a profile of the data to see that senior citizens here are represented as 65 and older and 65 plus. So if I were to write a query and I had to put a where clause on my data, I can remember that I have to filter out these particular values, 2 of them, not just 1. And so overall, this process, what it does is it establishes, through the power of automated metadata, a sense of trust, a trust based on proxy, which is who else is using it, a trust based on lineage, which is where this data is coming from, and a trust based on recency, which is how recently has the data been updated. And a combination of all these factors derived mostly from automated means can really help move an organization forward in the direction of enabling data users to be more impactful, more productive, as well as enabling data producers, who are data engineers, BI folks, to understand and stay on top of usage patterns so you can then notify downstream consumers when you are deprecating a particular column or there's an incident in a particular data set. So also automatically populated as a part of this system is usually a lineage graph, which shows you, if we were to go back to the same data set, which shows you where does this table come from. So not only you have the same upstream as a list, but you can see them as a graph and be able to browse through that graph as well. Anyway, so this is the core of a solution that I created at Lyft to solve this problem there. And what I wanted to share with you is the impact this had at Lyft. So to share a little more with you on that, here is a graph of usage of Amundsen at Lyft. And a few things to note is that Lyft has about 250 data scientists and analysts. There were 750 users using this automated data catalog at Lyft every single week. That means there are 3x more users who use this product every week. And these product usage was always going up and to the right. You notice that, for example, in December one year, like there's a huge dip, and obviously that's because everybody's on holidays. And so that's just like tracking the day-to-day usage at the company. And to give you a sense of who were the users who used this at Lyft, you would find that the left bar, the green bar, shows the total number of users with that role, and the red bar shows you how many users used this data catalog the week prior. And so the ratio is more important. We call that the penetration rate. And I've listed out the ratios on the right-hand side to make it easy for you all to consume. The data scientists or analysts, there was 80% penetration at Lyft. And research scientists, or in the broader context, data scientists, these are research scientists at Lyft were folks doing more ML style work, while data scientists were folks doing more insights style work. And so research scientists had 70% penetration. These were the primary users, really great penetration. And then you find these other roles. The product managers had 22% penetration. Software engineers had 17% penetration. And let me explain why that was the case, because at Lyft, there was no distinction in titles between a data engineer and a software engineer. So all data engineers were considered software engineers by title. And we found that there was a very heavy penetration rate in data engineering team, but in the broader engineering team, because they're mostly working on developing mobile apps or services, there was not a whole lot of penetration, which makes sense. So if I were to calculate the penetration rate amongst data engineers, that was pretty high as well, 80%. And then you see a long tail of business users who were using this product in order to make data accessible to them. And that was really the power of this thing. This thing really helped data users at the company quickly established what was trustworthy, mostly through automated means. And then what we did was we open sourced this product. This product is now open source. It's used by 2,000. It has more than 2,000 members in the community, and it's used by more than 35 companies. And these companies are companies like Reddit, ING, Square, Brex, Convoy, iRobot, so on and so forth. And then if I were to look at this product and step back, trust in data is actually three things. The first one is an automated data catalog, and that's the category that we've been talking about thus far. This category ensures that you're using the right data, that you have the lineage to understand how this data is being used. But the second category on top of that is data classification. This is when you can automatically classify what data sets contain what information, particularly what data sets contain sensitive information. This is super helpful for regulations like CCPA, where you then have to report and delete information that's sensitive. So can we take samples of our data and then be able to say that I know where all the names are, I know where all the email addresses or phone numbers are, and therefore reduce the liability the organization has. And that is trust from an enterprise perspective. And lastly, trust comes from quality, right? So what we haven't talked about today at all is how do you ensure good quality data gets delivered on time? There are two ways to do that. One is to curated data quality tests. So these are kind of like unit tests on your data, and they allow you to essentially say that this particular column will always have less than 2% nulls, or this particular table will always have record count within 10% of the record count of this other table, so on and so forth. And so when we start to think about trust, we as organizations have to invest our energy in three different places. Automated data catalog that helps users quickly understand and trust data. Data classification that helps the enterprise quickly know where is sensitive data in the warehouse and be able to audit that. And data quality products that allow us to quickly understand curated and automated checks to understand the quality of the data. And if you were curious about some of the products that exist in this space, I put some logos here. So we talked a bunch about the automated data catalog. There is data classification system. AWS has Macy that allows you to now send samples of your data and be able to tell you what's sensitive and what's not. And Google Cloud has a similar construct called DLP, or data loss prevention. And on the data quality side, there are 4 products that I mentioned. There's DBT Tests, which comes as a part of DBT. Great Expectations is an open source project. And then 2 companies, Monte Carlo and Big Eye, are also pretty commonly. And lastly on automated data catalog, Amundsen is the project I created at Lyft, and then Stemma is a managed version of that product that falls in that category. And so to look forward in the future, the way I see this is that I started my journey at Lyft creating this automated data catalog, Amundsen there. And as a part of that, captured a bunch of metadata. This is information like, when was this data set last updated? Who else uses this data? What's derived from this data? How often is this data updated? When does this data usually get updated? And as I was working on Amundsen, I realized that the metadata that powers Amundsen is actually valuable for all these other applications. And so as CCPA, California's version of GDPR rolled in 2020, that metadata became the centerpiece for complying with CCPA at Lyft. And therefore, the realization came that data classification could feed into the same metadata as well as leverage the same metadata. And when I see the future, these 3 categories of data trust that I talked about, I see them sharing the same metadata. I see the data quality system sending the data catalog system a sense of what tests are passing and what tests are failing. And I see the same way that the cataloging system sending lineage to the data quality system so they can establish which downstream tables to notify based on a test that failed. And the applications here are countless, but that is all to say that the holy grail for solving for trust in data lies in applications like automated data catalog, data classification, quality on top of a single pool of shared metadata. That's all I had to share today. I wanted to leave enough room for questions, so we can head over there now, and appreciate you attending.
Mark, thank you so much for that really interesting and thought-provoking presentation. I personally enjoyed it a lot, and I think I might have to get myself one of these Amundsen tools for my organization. Now, I will encourage everyone online to ask questions in the Q&A section of your screen. So I can see there are already some questions there that have been asked by the audience. So we'll go to them very shortly, but please make sure you interact with this platform and ask everything you want to know of Mark today. So Mark, the first question and highest voted question here is, will it be possible to get access to your slides from today?
Of course. Yeah, happy to.
Yeah, okay. And I might add in that connection, if the audience is interested in getting in contact with you generally, how can they do that?
Via my email address or on Twitter. So my email is mark@sema.ai, and on Twitter, I'm mark_Grover.
Yeah, great. And another question here from Mayuresh is, how do you actually calculate the trustworthiness of data?
That's a great question. And I have a story around this question. So at Lyft, I was battling the same question. How can I actually maybe attach a score to a data set and say this data set is 90 out of 100 trustworthy, or this data set is 10 out of 100 trustworthy? And I built a raw model of this, and I showed it to some data analytics users, one from a group that was Lyft Bikes and Scooters, which is a rather new group coming up, and one from the finance team, which has pretty solidified data sets that are being worked on. And the feedback I got from both the users was, I do not want a trust score, because that tells me that that's not transparent to me. I don't know how you calculated it. I would rather you tell me all the features that you were going to input in order to calculate this trust score. And so that is why a product like Amundsen or Stemma starts looking like it has a bunch of metadata that's pretty high density information. That's because analysts like yourself, Jonas, are like a cynical bunch. They want transparency into like, why is this the way it is? And so that is to say that it's intentional that there's no score of trust associated with the tables. But if you were to take all the features, quote unquote, that go into calculating the trust, those would be, how often does this data get updated? When was it last updated? What's the date range for which this data has data? How many people consume it? How many dashboards are built on top of it? What tables are built on top of that? And so on. And I think those are predominantly it. Those would be how you would calculate that score.
Yeah, it's interesting. I can see it myself, the use cases for this in terms of not having this tool in an organization, and the fear of changing a data variable somewhere in the warehouse and not understanding what the downstream impacts of that is. You've just answered there a good use case for that. Marian asks, what is the underlying programming language or package used to develop the graph model?
Yeah, great question. I didn't get a chance to dig into the architecture of a product like this in detail in the presentation, so I'll take a moment to describe that now. Usually, it requires 4 things in order to build a product like this. The first thing is a front-end service, which is your React, Django. I'll get to your question, Marianne, in a moment. The second thing is an Elasticsearch or a search service that powers the search interface that you saw. The third thing is a graph model that's storing all these relationships between tables, people, column, dashboards, so on and so forth. And the last thing is an ingestion system or an ETL system that is bringing all this metadata into the graph database. And so specifically for the graph model, what Amundsen's incarnation used was a Neo4j graph by default. Since then, we've added support for Postgres or MySQL, like a relational database, as well as Neptune, which is another graph database, and that's how that usually ends up working.
Thank you. So we have another question from Skiamantas, and I'm hoping I'm putting the right meaning into the question. So what's an efficient way to for the clients of the solution to actually establish that your data is trustworthy?
Yeah, so my read of that question is, how can a user who's using this data maybe give you a feedback loop on whether that thing that they ended up using was good or not? And if so, I actually find that users love complaining about data. And in fact, I think often users of the data have more context about gotchas of the data than even producers of the data. The sad thing is users of the data often don't feel comfortable updating descriptions or like putting big banners saying this thing is bad, right? And so it requires a little bit of practice in social engineering that I was able to do at Lyft in order to kind of fine tune this. Initially, what we did was made it easy for anybody to update a description in the hope that a user could come in and say like, oh, this table is busted, please don't use it. What we found was it is very hard. A user doesn't feel comfortable updating a description, but they feel very comfortable filing a bug report on the table. So so one thing that I perhaps didn't dig into the demo was that there is a button that says, let me actually just show you instead of talking about it. There's a button that says report an issue. You type in your issue. There's an issue with this table. You type in a description. It files a JIRA ticket and starts showing up on this particular page. And that is the way that users are able to communicate that there's something wrong with the table, right? And I think that's where we are today in the sense of communicating bad things. I do think that there is a need to communicate good things, maybe a thumbs up or a star or something like that. But that's a work in progress.
Yeah. So audience, please keep asking questions if you have more questions of Mark. I have a question for you, Mark, because what you just showed there is that there is a technical solution in one corner, but there's also actually communicating that to the audience or the users. And there's a lot of psychology in between that, in how you present up information and get information and feedback from the users. So what has been the most surprising use case or insight from having seen users use this platform?
Yeah, great question. I'll share one with you that I think in retrospect isn't surprising, but it was surprising when we were in the middle of it. And the learning was that, let me go back to this example that I was sharing with you of the Slack channel where people were asking all these questions. And I just thought that when they had this data catalog at Lyft, they would stop asking these questions. And what I realized after the catalog was there was that they were still asking these questions on Slack. The nature of questions had changed. Instead of being, where is this data? What does this table mean? Or what does this column mean? Is this still up to date? The questions became more nuanced. Oh, there was an incident yesterday, and I want to reimburse all the drivers who couldn't give rides during that incident. And I want to find out, where do I get the people who were impacted by the incident? Where do I get information about their potential earnings during that time? So I can then go and reimburse them, right? There's no way you can answer that question in the data catalog. You kind of have to like talk to somebody or have a conversation about it on Slack. And initially, my gut reaction was to force these people to have these conversations on the data catalog. Oh, you're asking about this thing, you should go update this table. But over time, I learned that if you don't have to change user behavior, but you can actually influence their current workflow and improve it, that's a much better way to do it, right? And so what I learned thereon was, instead of forcing people to not talk in their best of breed product, which is Slack, and talk in the data catalog instead, what if there was a Slack bot that attached relevant conversations that were happening in Slack to the various table and dashboard pages that were happening in the data catalog product? And that's been one learning that's kind of stayed with me, that it's always better to be in the flow of the user's workflow, whether it's when you are getting information. So if someone is creating a new event, you want to enforce that they add documentation or the right type or a right classification then. Or when someone's consuming information, you want to make sure that whatever their workflow is, if that's Slack, you embed in that and you improve that workflow instead of forcing a change in habit, because habits die hard.
Yeah, and I think what I'm hearing you say is also that the users actually, the end consumers of the data science outputs actually become better question askers because they actually practice using the data to some extent, and they understand the dimensionality of data, whereas they're potentially typically used to just getting the output without understanding how you got there. But now they're seeing the raw materials, which I imagine can be quite a mindset shift for some business users. Now, one question attached to that. So earlier in your presentation, you talked about business owners being connected to this data. I'm personally one who tries to, as a data scientist, a data science leader, try to create connected, shared responsibility for the quality of the data with the business owners. How does this tool kind of feed into a process like that?
Yeah. I see quality in two different ways. One is semantic quality, and that means that we have a shared understanding of what fields. Oftentimes you may have a nested field and you want to make sure that that particular field is always filled with a certain number of attributes or certain style of metadata. And then there's business quality, where there's information that is domain specific. Like the financial line item column can only have 7 different kinds of line items. And your financial business user may know what those 7 line items are. They would also be the one to know when the 8th one gets added, right? And so that enables the data science team and the business team to then work together to understand what are the various domain-specific attributes and be able to put that information in the data quality product. That, by the way, is a separate product. We mostly saw the data catalog product, and the data quality product will enable you to put that information in there. That's how I see those two interrelated. Now, the integration between the data quality and the data catalog product is that the data catalog product should be able to show what are the various quality tests that got run on the table, what was the health of those tables, and that information comes straight from the quality tools API. And in the same way, the data catalog product can show automated documentation based on what tests were run on the table. For example, if a column is not expected to have null, that's really great documentation for the column because everybody knows that this column cannot be null. Or if a column is only expected to have 7 values and you list out those 7 values, that was a data quality test, but it's also great documentation. And so that's where I see a lot of integration and benefit there as well.
Yeah, okay. We have a question from Asad, who asks, do you store a formula about the transformation for particular columns between tables when you apply a mutation of incoming values?
We don't store a formula today. We store a link to the transformation. So that could be an Airflow task run that made that transform. I think the future here looks that we will store these mutations, and that would allow us to do smart things like if there was no transformation, we can trickle down description of a particular table or a particular column downstream, so you don't have to rewrite the same description over and over again. However, being able to store the transformation and knowing if that had a material effect on the column or not is something non-trivial that we haven't quite figured out. So right now, we only store a link to the mutation solely for the purposes of tracking. So our data engineer perhaps can go from the table to the task run that actually updated the table last. But our goal in the future is to be able to store the mutation, and especially in case of no mutation, be able to translate and trickle down a bunch of interesting metadata downstream.
Okay, so I will give the audience one last chance to ask a question before we finish up this conversation. But while people have a think, I might finish off with one of my last questions, Mark. So you seem like someone who's thought a lot about how to optimize time in the data science process. How do we best avoid this constant interruption from the business in a process that's really sort of very creative and requires deep thinking?
Wow, that's an excellent question. I think this question is actually more broad. It's for all builders, and whether you're an engineer or an analyst, you have this problem, and partly it's a I'm thinking out loud here, but I think partly it's a product problem, partly it's a process problem, and partly it's a people problem. And so product problem the data catalog you saw is a prime example of a product that can help you lower down interruptions by standardizing and putting in some information that is helpful and directing people to that information instead of asking questions on Slack by default. Process problem is oftentimes in organizations, we start to value expediency of response, right? But every time you have an expedited response means that whatever they were doing, deep work they were doing, was interrupted to give you that response, right? So there's a bunch of like reward structures we set up that actually incentivize people the wrong way. And that's the process problem. And so having set up SLAs is actually a really good way to work around that problem. And if you have a business stakeholder asking you for analytics, you could say like, hey, this kind of analytics is available on a 7-day cadence, or unless there's a Sev0, like the SLA is 1 business day, things of that nature. And so that was product. Then we moved on to process. And lastly, it's people. I think there is honestly a certain sense of dopamine you get out of responding to somebody, seeing a Slack emoji. And there is like, they're playing with us. It's the same thing that I think happens sometimes in social media. And I think just being mindful of that as individuals, and if more deep work is something you want to do, tuning off those sound notifications, turning off Slack, maybe putting a banner on Slack saying like, if you need me urgently, text me or DM me or mention me, things of that nature. Changing your Slack notifications help a lot with that work. And to each person, it's their own here, so there's no like one size fit all. But that would be the third thing I would think about there.
I'm almost embarrassed to say it, but when I put my phone outside my office, my productivity typically doubles in a day. One last question from Joachim. So, what size of a company does it make sense to introduce a tool like Amundsen, considering the effort associated with managing the tool?
Yeah. So we'll talk about just the benefit, and we'll keep the cost aside. The benefit, actually, you need to have a certain sense of chaos, I don't have a better word for this, in the company in order to benefit from a product like this. Why? Because if you don't have quote unquote chaos, and the chaos can come in 3 different ways. The first chaos is you have too much data and it's growing really fast. The second is you have too many people coming into the company or moving teams or leaving the company. And the third one is you have a lot of silos or legacy systems that are hidden in various different areas. When you have that style of chaos, you find that there's no one person that can house all this information in their head, and you don't walk up to be like, oh, Jonas, like, can you help me figure this out, XYZ, right? And so when you have one of these dimensions, that's a good time for you to start investing. I find that usually happens when a company gets to about 200 knowledge workers. So 200 employees, assuming it's a tech company, I'm not talking about Walmart or something like that, right? So when you get to 200 knowledge workers or so, and you're growing at a reasonable pace, maybe 10% year over year or more, that's when you start investing a product like this. In terms of what it takes to deploy Amundsen, Amundsen is an open source project with a bunch of services. So it takes 2 engineers 3 to 6 months to stand this thing up. Obviously, the Stemma managed version is much easier to stand up and has a bunch of additional automation and proprietary additions that make the deployment only a matter of weeks.
Fantastic. Mark, we're at the end. Thank you so much for your time on behalf of the audience. Very enlightening. And thanks for sharing further knowledge in this Q&A session. And also thanks to everyone in the audience who asked the question, because it's a really helpful way to get more out of the conversation for everyone involved. Okay, so 5 past the hour is the next speech or presentation at wherever you want to go. So we're starting on the streams now. So please head over there and enjoy yourselves throughout the day. You have 5 minutes to get a cup of coffee or tea or otherwise. And Mark, thank you so much. Enjoy your, I guess it's evening where you are, I'm guessing.
It's midnight. Yeah, I'm going to go to bed.
Okay. Good night.
Good night. Thank you for having me.
See you later. Thanks.